Hello everyone, and welcome back to the show. I'm your host Sam No-ai. And I am super excited to be here with you today. Today is Saturday, June 6th, 2026. It is a wonderful weekend. And I hope you are all having a really fantastic day so far. Today, I'm introducing a super trending article from the archive. And it is honestly so mind-blowing. We cannot wait to share all the cool details with you. It is a bit technical, but do not worry at all, because I am going to break it down so it is super easy and fun to understand. So the title of the paper is LLaMA Adapting Video Codecs for Efficient Weight Compression of Large Language Models. And the curl is pets.colon/arxa.org/ABS/260/6.05861V1. It is long, but it is packed with such amazing information. This paper comes from researchers at Shanghai Jiao Tong University. And they are tackling a really massive problem in the world of artificial intelligence. Let us start by talking about the problem that this paper is trying to solve. As you probably know, large language models, or LLMs, have become incredibly smart recently. They can write code, they can chat with you like a real person, and they can even search for complex information. But there is a huge catch to all of this amazing power. These models are getting absolutely gigantic in size. For example, a popular model called LLaMA 370 requires about 140 gigabytes of memory just to run smoothly. Put that in perspective. You would need at least 2 super expensive top-of-the-line graphics cards just to use it. That makes it super hard to store, transmit, and deploy these models for everyday use. It is like trying to fit a giant elephant into a tiny compact car. To fix this, scientists use something called model compression. The most popular method is called quantization. You can think of quantization like taking a super high-resolution photo and shrinking down the file size by reducing the number of colors. It makes the file smaller, but if you compress it too much, the picture gets all blacky and ugly. In the AI world, methods like bit or FlatMap compress the AI brain from a highly detailed format into a smaller one. But when they try to squeeze it down to just 2 bits per parameter, which is a super extreme level of compression, the AI kind of loses its mind. It forgets how to do things properly, and its performance drops significantly. This is where our researchers come in with a totally genius idea. Instead of just inventing another basic quantization math trick, they thought outside the box. They asked, what if we use video compression technology to shrink down the AI? Yes, you heard me right. The exact same video bodies that shrink down the movies and videos you watch on your phone. They created a framework called LLMCodec. They realized that the brain of an AI is basically just huge grids of numbers, which are called matrices. And guess what else uses huge grids of numbers? Video frames. So, they decided to treat the AI weights like a series of video frames, and then use a highly optimized video in order to compress them. Now let us dive deeply into how they actually do this, because the details are super fascinating. Before they turn the AI into a video, they have to fix a little problem called outliers in these AI number grids. Most of the numbers are pretty small and normal, but every now and then, there is a huge, crazy number that sticks out. If you try to compress a picture with a giant bright spot in the middle, the video compressor gets really confused and messes up the rest of the image. So, the researchers use something called the lambda transformation. This is basically a fancy way of flattening out those crazy spikes, redistributing the values so that everything looks nice and smooth. By doing this, the numbers become much friendlier for the video compressor to handle. After smoothing things out, they use a simple method called round to nearest quantization. or RETN for short. This turns the super detailed floating point numbers into simple 8-bit integers. Once they have these 8-bit integers, they map them into a format called U420. This is a standard format used in video processing. In U420, the image is split into brightness, which is the Y channel, and color, which are the U and V channels. Because the AI numbers do not actually have real colors, they stuff all the important brain data into the brightness channel and just fill the color channels with constant blank values. This is so clever because the video compressor does not waste any space on the empty color channels, keeping the file size super small. Then they feed this data into a modern intelligence that are called VE, which stands for Versatile Video Coding. It is also known as H.26. They specifically use a profile called intra in more videos. Frames rely on the frames before them to save space, but for an AI, each layer of the brain is totally unique. If one layer gets messed up because of a bad prediction, the whole AI becomes stupid. So the Nature profile treats every single layer as its own independent picture. This ensures that the compression is stable and every part of the AI retains its high-quality intelligence. Let us compare this with the older technologies. The results are actually mind-blowing. When they compress the LLaMA 3.8 model down to just 2 bits per parameter, the older method called LLaMA struggled a lot. Well, LLaMA reduced the perplexity by over 36%. Perplexity is basically a measure of how confused the AI is, so nowhere numbers much better. Not only that, but the average accuracy on complex reasoning tasks improved by 21% compared to the older methods. They also tried other video lows like CHPEG, and H.265. But the newest value threw them all out of the water, preserving the AI precision beautifully. So, how does this apply to everyday life? Why should we care about squashing AI into video formats? Well, let me give you 3 specific application examples of how this technology will change our world. First of all, imagine running a super advanced, human-like AI completely offline on your everyday smartphone right now. If you want to use a really smart AI, your phone has to send your data to a giant cloud server. This takes time, eats up your data plan. It can be a huge privacy risk if you are talking about personal stuff. With LLaMA, the massive AI models can be compressed down so small that they actually fit right into your phone memory. This means you can have a brilliant personal assistant in your pocket that works instantly, even if you are in a tunnel with zero internet connection. And because the AI stays on your device, your private data never has to leave your hands. The second amazing application is in the world of smart home devices and robotics. Think about your smart speakers, your robotic vacuum cleaners, or even smart security cameras. These devices have very tiny computer chips and almost no memory to keep them cheap and affordable. Normally, they are pretty done without an internet connection. But by using this video compression, companies can cram highly intelligent language models into these tiny home gadgets. Your robot vacuum could understand complex, natural voice commands like, "Please clean into the dining table," to avoid the dog bed, and it would process the thought instantly using its own time. Compressed brain, making our homes much smarter and more responsive. The third big application is in the transmission of AI updates over standard networks. Just like how your phone gets software updates, AI models need to be updated to learn new things. But downloading the 140 gigabyte file over a regular cellular network would take forever, and it would probably cost a fortune in data fees. Because LLaMA uses highly optimized video compression technology. These huge AI updates can be streamed and downloaded almost exactly like watching a high-definition YouTube video. This means hospitals, Schools and businesses in remote areas with slow internet can quickly download the latest medical or educational AI models. It democratizes AI, making sure that even people without fancy fiber optic internet can access the smartest tools in the world. Isn't that just incredible? By looking at a new problem through the lens of an old, reliable technology like video compression, these researchers have unlocked a whole new path for artificial intelligence. It just goes to show that sometimes the best solutions come from combining two completely different fields of study. I'm really looking forward to the day when my smartphone can think like a supercomputer. All thanks to some clever video and coding tricks. Well, that is all the time we have for today. Thank you so much for tuning in and geeking out with me over this awesome archive paper. I hope you found it as exciting as I did. Have a wonderful rest of your Saturday. Enjoy your weekend, and I will catch you all next time. Stay curious, and bye-bye.